Hello and welcome to YouTube channel Tech Guru Gautam Prasad. Uh, this is a video on steel manufacturing in different grades, and hope you are already subscribed. And if you are not subscribed, I will suggest you to subscribe to this channel so that you keep getting the link of the updated videos on this channel. So let's proceed. So here, in the process of steel manufacturing, the first raw material that we use is the iron ore. Iron ore are of four basic types. So one is called magnetite, other is hematite, yet another is siderite, and the last one is limonite. Hematite is Fe2O3 as its chemical formula and contains 70% of the iron ore. Magnetite at the same time is Fe2O3 and it contains 72.4% of the iron content. Limonite is 2Fe2O3 dot 3H2O, which contains 59.8% of the iron. Siderite is Fe2 FeCO3 and that contains the least amount, that is 48.2% of the iron. So you can see magnetite is the richest in iron content, whereas siderite is the poorest in the iron content. This is the steel mill life cycle before it reaches to the mill and it is converted into the final product. It has to pass through different processes. Uh, the steel is first primarily manufactured in the blast furnaces, and the iron ore, coke, and limestone are the basic raw materials for the production of the steel. But it produces raw steel. The blast furnace produces the raw steel, and in order to convert it into different grades, it has to again be treated in the basic oxygen furnace, where the oxygen is blown with the help of a lance from the top, and the extra amount of the carbon that it has is burned and converted into the desired grade of the steel. So after the blast furnace, the hot metal reaches to the basic oxygen furnace, and then it is sent to the caster, or it is molded directly in the form of ingots, and that is rolled further. In the continuous caster, we can cast blooms, billets, and slabs, and they are further rolled. They could be hot rolled or cold rolled, and thus the products could be uh, hot rolled coil or cold rolled coil or structural or bars, anything like that. Another process of steel manufacturing is recycling of the steel. So we get scrap from the different industries, old industries where the old industry is dismantled, or uh, steel is coming out of that. That is put into the electric arc furnace, and uh, in the arc furnace, it is melted, and with the help of electrodes, basically, it is the extra amount of the carbon, and due to the addition of different types of materials in that, we get the desirable grade of the steel, and then it is again processed in the continuous caster or molded into ingots, and they are further rolled in the form of bloom or the billet or the slab, and they are further rolled in the form of uh, cold rolled coil or hot rolled coil, or it is rolled in the form of a channel, or any kind of structurals that is used in the construction industry, or bars. So this is the complete life cycle of the steel mill. Here you can see the blast furnace process. This is very important process, and you have uh, the raw materials to be put from the top. Basically, these materials are iron ore, coke, and limestone. So this is put from the top and it falls here, but does not fall to the bottom. It keeps hanging in the uh, air at this place, and because hot air blast is, you know, uh, uh, given from the bottom, and this keeps the entire material suspended in the air, and the exothermic reaction keeps going at this place, and as you can see, the this whole part of the uh, blast furnace is having a lining of refractory material to bear the higher temperature. Otherwise, the iron uh, part of the blast furnace will just melt. So this refractory lining is a must in the case of blast furnace. Let's just see how this chemical reaction inside the blast furnace goes. So you have got, CO2 and coke basically mixes to produce coke oven gas, uh, CO gas, not coke oven gas, basically CO gas, and hot air reacts with the coke to produce carbon dioxide, and this CO, reacts with Fe2O3. Fe2O3 is the iron ore, considering this is the iron ore, and this CO acts as a reducing agent basically here, and Fe is freed as a result of this chemical reaction, and CO2 is produced. Also, at the same time, calcium oxide, that is limestone, reacts with SiO2, that is silicon oxide, and these two mix up to form calcium silicate, and that is nothing but the slag formed in the case of this steel production. So, slag is lighter than the hot metal. That basically the hot metal contains the iron, that is further to be treated in the form of steel. So this collects at the bottom, and the bottom part you can see molten iron is there, and molten slag is just floating on the surface of the molten iron. And first, molten slag is tapped, and then molten iron is tapped, so that they don't mix up together, and the quality is not degraded. So this is the whole process of working of the blast furnace that I explained. A real blast furnace has been shown on the right side of the picture, where you can see in the real life how does it uh, look like. So hopefully you have understood it properly. Let's proceed. This is the detailed view of the blast furnace. Sometimes the blast furnace temperature inside this blast furnace goes up to 22,000 degree Fahrenheit, and 3,400 degree uh, Fahrenheit at this level. So on the higher side of this blast furnace, temperature is lower as compared to the bottom side of the furnace. So as the reaction going on inside the blast furnace is exothermic in the nature, so no additional fuel is required to keep it hot. So the for the raw material to be put from the from the top of the blast furnace, you have got an arrangement that is called, a skip car loading. This material, raw material, is put from, you know, there are hoppers basically, and scale, weighing scale is there. So it is the quantity is measured here, and that is poured into the, put into the skid car bucket, and this is it has to travel all the way to the top of the blast furnace and pours the entire material into the blast furnace, and that goes inside. So coke, limestone, or iron ore, all these three materials are put from the top, and then this goes inside, and controlling mechanism is of course there at the top, which controls the material insertion into the blast furnace. At the same time, you have got tuyeres, to keep the hot air blast, into the blast furnace from the bottom, to keep this material hanging in the air. And these are the stoves, to put the for the generation of the hot air, and that goes to the tuyeres from here. Here also you can see the hot blast goes from this circuit, and this is the circuit of the hot gases coming out, and these hot gases are used for heating up the air. So this is quite you know a saving of energy. The hot gases that are coming out of the blast furnace, they are being used for heating the air, and thus the gases are recycled. When this material is produced, the slag car is there on one side, and on the other side you are having a torpedo ladle which collects the hot metal produced from the blast furnace. So this is how the entire process of the blast furnace works. But you will have to see to properly understand it. Once you visit the site of the blast furnace, then only you will be able to understand this whole process of production of steel. This is the primary stage. This is primary steel making, and the secondary steel making is done in the basic oxygen furnace. And the secondary part, focuses on controlling the content of additions that is done, different types of materials that are added into the uh, steel, basically to define the grade of the steel. It is focused on that. Here you can see the basic oxygen furnace has been shown, and the air is air plus oxygen is put into the basic oxygen furnace through a lance, and that blows the hot metal, and because of this blowing, the temperature enhances, and the carbon is burnt, and carbon monoxide and carbon dioxide are produced, as you can see here. In the process, they are collected and put into the gas holder. So they have got certain calorific value. That is why they are collected and kept into the gas holder for further use in different processes. You know, we have many furnaces at different places where the rolling mills are working. So in those furnaces, these gases are used for further heating the slabs or the billets or anything like that. So lime or coal basically are added from the top, so that has got a different mechanism. You have got a weighing scale and hoppers to put the material into the basic oxygen furnace. From there, this is basically a vessel, and this vessel has got a tilting mechanism, and the steel manufactured in such a manner is put into the uh, steel ladle, and then this slag is put into the slag ladle, and thus the separation is done. So here in another picture, you have been shown how this tilting mechanism is. This vessel, this is the vessel part, and this is supported on two sides so that it can tilt, and on the bottom side you will have on one side slag car and the other side is steel car, and uh, steel car will of course carry the steel ladle and the slag car will carry the slag ladle, and this is tilted to pour the steel into the steel ladle. This is the entire mechanism of gas recovery or putting the raw material into this vessel as a part of the addition of materials basically. So sometimes coke is also added, limestone is added. So all these beans are kept here, and with the command from the uh, screen in the control room, only these materials can be added into the vessel. So here is the another picture of the vessel basically, and here you have been shown the hot metal brought from the blast furnace is being poured into the vessel for further treatment. This is called secondary steel making, and in the secondary steel making, basically we focus on the carbon content and other content of the steel. Basically, some addition is done as per the grade of the steel, and that particular grade is produced. This chemical composition is checked. There is something called RAC lab, Rapid Analysis Center, and that has got a spectrometer basically. The sample is taken from this vessel and the sample is sent quickly to the rapid analysis center, and that center analyzes and sends the report to the control room, and if no further addition is required, then this steel is poured into the steel ladle and sent for casting or you know uh, uh, casting or different processes. Let's now understand different grades of the steel. Steel is produced in different grades basically. Steel grades are broadly categorized into carbon steel, alloy steel, stainless steel, and tool steel are the basic types, each with subcategories based on the properties like carbon content and alloying elements, influencing their strength, corrosion resistance, and other mechanical and sometimes electrical characteristics. So, what is carbon steel? Primarily composed of iron and carbon with varying carbon content influencing its properties. So, you have different categories on the different, the levels of the carbon. Low carbon steel, that is also called mild steel, medium carbon steel, and then high carbon steel. Low carbon steel contains 0.3% of the carbon, known for its ductility and weldability and relatively low cost. Medium carbon steel at the same time contains 0.3% to 0.6% of the carbon, offering the balance of strength and ductility suitable for applications requiring high strength than mild steel. And the third one is high carbon steel that contains over 0.6% of the carbon, resulting in high hardness and high strength, but with reduced ductility. Applications of carbon steel are in the construction industry, manufacturing industry, and various, you know, uh, uh, general purpose applications. Alloy steel is another type of the steel, contains other elements besides iron and carbon, enhancing specific properties like strength, hardness, and corrosion resistance. So we have two types of the alloy steel. One is called low alloy steel, and the other is called high alloy steel. Low alloy steel contains a small amount of alloying elements, offering improved strength and toughness compared to carbon steel. High alloy steel contains a higher concentration of the alloying elements, resulting in a specialized properties for specific applications. And the applications of such, steel is heavy duty structures, machinery, and components requiring higher strength and durability. The third one is stainless steel, which is the most popular one and that you must have seen, must have heard about, contains chromium as the primary alloying element, which forms a passive layer that protects it against the corrosion. So, subcategories of stainless steel are austenitic stainless steel that contains chromium and the nickel, known for its excellent corrosion resistance and non-magnetic properties. Non-magnetic properties, they are not magnetic in the nature. And then you have ferritic stainless steel that contains only chromium, offering good corrosion resistance but with lower strength than austenitic stainless steel. Martensitic stainless steel contains chromium and can be hardened through the heat treatment, offering a balance of strength and corrosion resistance. Stainless steel examples are grade 304, a common austenitic stainless steel known for its good composition, corrosion resistance, and workability. Grade 316 is another austenitic stainless steel with enhanced corrosion resistance and particularly in fluoride environment. Applications of such stainless steel is in medical devices, food processing equipments, architectural applications, and other applications requiring high corrosion resistance. Tool steel is another type of the steel. So, tool steel is basically designed for use in tools and dies requiring high hardness, wear resistance, and ability to withstand high temperatures. This is talking about the temperature in tools and dies because of abrasion, because of friction between the tool or the die and the surface it is eroding or machining sometimes that it is talking. So examples of this tool steel are A2, a cold work tool steel known for its high hardness and wear resistance. D2 is another work steel, cold work tool steel offering excellent toughness and wear resistance. M2, a hot work tool steel uh, designed for high temperature applications. And the application of tool steels are cutting tools, dies, molds, and other applications requiring high performance. Thank you very much for patiently listening the entire lecture and hope this has enriched your knowledge about the steel manufacturing in different grades. It has also explained you the basic process of basic blast furnace process and a secondary steel making process in the form of a basic oxygen uh, furnace, that is a treatment of the hot metal uh, by putting it into the ladle. So, thank you so much once again. If you have not subscribed to this channel yet, then I will request you to subscribe to the channel for further getting the notifications of my new videos. Thank you.